Good morning, everybody. Thanks for attending today. Well, actually, may or may not be morning where you are. It's morning where I am. So I want to thank you again for joining today. This is the Population Dynamics and Health Program workshop on recent advances in differences with Jonathan Roth of Brown University. So welcome today. While you're getting settled, I like to always take a couple minutes to sort of plug our center and just orient everybody about the Population Dynamics and Health Program in case you don't know who we are and what we do. So while you're getting settled, I'll be talking about that, and then I'll hand over to John in just a couple minutes. So if you've registered for this workshop formally, you'll have touched our website, so you should be at least a little bit familiar. But I wanted to kind of walk everybody through our website, which is pdhp.isr.umich.edu. We are the Population Dynamics and Health Program. We are located in Ann Arbor, Michigan, on the campus of University of Michigan. And we support population science really in all its forms. And so we're funded by the NICHD, which is the National Institute of Child Health and Human Development, and specifically the Population Dynamics branch. And so we are charged with supporting population science and specifically with early career scientists. And so if you fit that bill or you work in that area, please feel free to reach out to us. We have a faculty affiliate program, which unlocks some kind of special services for you if you're interested, including free statistical consulting with our team, myself, Brady West, and our other data scientist, Jiaxu Zhao. So if you're interested in that, please reach out. We also offer a paid mentorship program, again, for early career scientists that you can tap into mentorship and actually get part of your salary paid for to go through that mentorship program. This is all outlined on our website here. I've got it on screen so you can take a look. We've also got a small grants program that can fund technical aspects of your research, including software licenses and also a more full range of actual project work. So that's all I'll say about the website. Just feel free, if you're interested in learning more, you can reach out to me directly, or you can just browse the website. And again, I'll leave it at that. One thing I'll say about the website, in terms of the workshop series, we've got 2 or 3 years now of past workshops. And so if this is your first time being with us for a workshop, please feel free to peruse our past workshops. If you go to the workshops tab, we've got a little link down here that says view past PDHP workshops. And if you scroll down to there, you'll see all our past workshops going back to 2018. We don't have video for all of them, unfortunately. We lost some in the cloud here and there, but we're building a video archive, and we've got all our slides and materials online. And so feel free to browse this section of our website. All the videos are hosted on YouTube, where we've got a YouTube playlist as well. So you can just go directly to YouTube if you'd rather just go straight to the video. So that's enough about us. For the website, or for the workshop today, you're muted by default, so you don't have to worry about your sound leaking. If you've got questions, please chat them. I'll be monitoring the chat while John talks, and John will control sort of how much audience participation he wants, but feel free to chat in your questions. Especially if you've got technical questions with the audio or anything like that, I can help with that live. If you've got substantive questions about the workshop, we'll probably wait until we get to a natural breaking point, and we'll handle those with John directly. So again, welcome aboard today. That's all I'll say, and then I'll introduce our speaker, and then we'll be off and running. So our speaker today is Jonathan Roth. He is, lost my screen. He's an assistant professor in the economics department at Brown University. His primary research interests are in econometrics with a focus on causal inference. He's also worked on topics in labor economics and algorithmic fairness. Prior to coming to Brown, Jonathan was a senior researcher in the office of the chief economist at Microsoft. He obtained his PhD in 2020 from the Harvard Economics Department, where he was awarded the David A. Wells Prize for Best Dissertation. He received his BA in Mathematics and Economics summa cum laude from the University of Pennsylvania. So we're very excited to have John today. I will be done talking now, and I'll hand over to him. So welcome aboard, and I hope you enjoy the workshop today.
All right, thank you so much. Let me just share my screen here. All right, thank you, Paul, and everyone at PDHP or ISR. I don't know what the right acronym is. Today I'll focus on a different acronym, which is DiD. So excited to learn with all of you today. So welcome to the workshop. Every time I do one of these, I feel like I at least learn a lot from everyone's questions. Hopefully you'll learn a lot too. Paul mentioned that we can sort of do questions as I like. What I like to do the most is to have as much participation from the audience as is feasibly possible. Of course, with 275 of you, we can't have each person ask 10 minutes of questions, but I encourage people to participate as much as they can. So I think practically what that means is either drop a question into the Q&A whenever it comes up, or raise your hand on the Zoom and we can try unmuting you and have you ask the question out loud. So I'm gonna encourage as much participation as is feasible in a seminar this size. I guess before I start talking to you, I guess it's always helpful for you to have a little bit more background of who I am and what I can tell you guys about. So as Paul mentioned, I'm an assistant professor at Brown, and I consider myself an applied econometrician. So the main goal of my research is to develop usable tools that can improve the quality and transparency of empirical work. And so to give you a little bit of background as to how I got into this field, early on in graduate school, I was not really an econometrician. I was kind of interested in econometrics, but my primary focus was labor economics. And as many labor economists do, I wound up running a bunch of difference and differences design. So in particular, I was working on a project about Wisconsin's Act 10. This is Scott Walker's big union reform. And I was looking at how that impacted teacher labor supply and teacher quality. And so what I found was that around the time of this Act 10, a lot of teachers in Wisconsin retired early. They wanted to lock in the benefits, retirement benefits that were collectively bargained before kind of this union busting reform went into place. And so then I was trying to analyze, well, what were the effects of these teacher retirements on student outcomes? And so I was running a lot of difference and differences designs. Here is an example of one of the event study plots from that paper. But I was finding that, some of my event study plots, like this one here, looked reasonably good, at least by conventional metrics. And some of them didn't look so good. And I guess I was kind of wondering, should I just focus on the ones that look good? Is that kind of the way science is supposed to work? Or should I have some doubts about the parallel trends assumption in this context? If I focus on the ones where it looks good and kind of throw out the ones that don't look good, is that okay? That seemed to be kind of what people were doing and what my advisors were encouraging me to do. But I was a little bit uneasy about kind of that practice. And so while I was interested in Act 10, pretty quickly I had a bunch of these methodological questions about how is it that we should be doing difference and differences kind of brewing in the back of my head. And so pretty quickly I kind of started writing methodological papers about these types of questions about how we should do difference and differences in general. And I kind of lost track of the Act 10 work, so I've never published that paper. For all the grad students and early stage researchers in the audience, I guess I would say, in general, having a working paper and then not publishing it is probably not recommended. On the other hand, finding a research area that you're really interested in and that you really enjoy doing, as I have with difference and differences, is certainly recommended. So, take what you will from that. But kind of my focus, since I kind of pivoted from doing this Act 10 research to working on more methodological stuff, has been kind of trying to answer these types of questions about how is it that we should be thinking about things like parallel trends, and how much can we learn from the data about whether that assumption is true, and what are kind of the limitations about what we can learn from the data about things like pre-trans tests. And so while I've kind of switched to methodological issues, the sort of goal of my research has always been to kind of inform real world analyses of economic topics. So I'm still very interested in things like, teachers unions, minimum wage, and stuff like that. And so my research, while, it's mainly theoretical, is always sort of targeted to being able to help applied researchers better answer these types of applied microeconomic questions of interest. And so what I hope to do today is share with you some of the insights that I've kind of learned over the last few years in collaboration with many outstanding co-authors, with the goal of helping you improve your research. And so I imagine that most of this audience is applied researchers who are, either using or thinking about using difference and differences methods in practice. And so my goal is to try and help you kind of think through the issues to make that research as sort of compelling and credible and transparent about its limitations as possible. And so my focus today is going to be not just on theory, but also about how you can apply this in practice. So I'm going to do some lecturing, but we're also going to have a coding exercise, and we'll also have a time, hopefully towards the end, what I call kind of an online open office hour, where I imagine many of you have sort of specific settings where you're using difference and differences and you're thinking about various issues. And I hope to be able to call on at least several of you to kind of share what are the problems, what are you thinking about, and then kind of give my reactions, which I imagine, if one of the 320 whatever it is of you have a question, there's a good chance that several other of you also have a similar or related problem. And so hopefully we can make some progress on the types of things that come up frequently in practice, both those that are sort of directly related to the things that I'll talk about today, but also just kind of general difference and differences problems. Okay, so the approximate schedule for the day is as follows. Obviously, we started just after 9, so probably everything will be pushed back by a few minutes. But what I'd like to do is, for the first 10 or 15 minutes, give kind of an introduction, a sort of helicopter tour, high-level overview of what's been happening in the difference and differences literature in general. And then I won't have time to talk about everything that's happened in the difference and differences literature in general. So I'll focus kind of primarily on the part of the difference and differences literature that I've been most active in, which is things related to testing for violations of parallel trends and kind of sensitivity analysis to what happens if, we're not sure parallel trends holds. And so the kind of schedule approximately that I'll follow is I'll give that brief introduction. I'll then sort of have lecture 1, which will be about problems. So kind of what could, we're not sure parallel trends holds. How can we kind of test for it? And then kind of what are the issues and limitations with those tests? I'll sort of hopefully get you sufficiently scared that everything you're doing is wrong, that we'll need to take a short break for everyone to go to the bathroom and get some food or whatever. And then we'll come back and we'll have a second lecture kind of thinking about solutions to these problems. So hopefully you'll be a little bit less scared when we conclude, because not all hope is lost. So kind of lecture 1 will be about sort of issues with the common practice of pre-trends testing, and lecture 2 will be about some solutions. And then we'll hopefully wrap that up around 11:45 or 12. And then I have a coding exercise prepared that you guys can do to kind of see how these tools work in practice. So we'll spend about half an hour doing that. And then I hope to have the last part of the workshop today, as I mentioned, be kind of an open office hour / Q&A, where if you have difference and differences related questions from your own work or on anything that I've sort of said throughout the day that we didn't get a chance to cover, we can kind of answer those questions live in whatever time we have left at the end. This seems like probably a good place to pause just to see if there are any questions so far, either about my background or logistics or what we will or will not cover today. I see someone says that there are still a large number of participants sitting in the original Zoom room. I don't know, Paul or Brady or someone else, if you guys are able to sort of, maybe one of you join the alternative Zoom room and kind of just make sure that they're all able to get here.
Yep, we sent Zach over there to get those people over here, and I'm also sending it out by email. So hopefully most of those people will be able to find the right link.
Okay, excellent. So hopefully everyone from the original Zoom room can get shepherded over here. So it looks like at least one or two people came from the alternative Zoom room. Someone asked, will the recording of the meeting be available? Yes. Christina asked, will I cover staggered differences? For the most part, the answer there is no. So Pedro Santana did this workshop last year, and basically the whole 4 hours was on staggered diff and diff. So I was told mainly not to do staggered diff and diff again. But I will talk a little bit about how kind of some of the stuff that I'm doing kind of interacts with the recent literature on staggered differences. So there'll be a little bit of a tie-in to the staggered differences literature, but for the most part, the focus here will be elsewhere. All right, so I think I got most of the questions that are in the Q&A. If there were any that I missed, feel free to raise them if there's still questions later. So let me just press on a little bit here. So in terms of the logistics of the course today, as I think I said this once already, but I'll say it again. I strongly encourage you all to participate and ask questions. So it's certainly much more fun to me to kind of interact with people rather than just kind of talking into the Zoom void for 4 hours. And I think, it helps people learn a lot better when there's kind of back and forth. It helps me to figure out which points are unclear and what things I should cover in more detail. So I know it's always a little hard in such large things to have so much interaction, but encourage people to definitely drop stuff into the Q&A whenever it comes up, and I will do my best to answer as many questions as possible. I see many people are already taking the lead here and dropping things in the Q&A. So I think that the main way probably is to put stuff in the Q&A, but you can also kind of raise your hand on Zoom and we can try and unmute people if you have questions. And we'll definitely be doing that for the office hour component. Okay, and I will pause periodically for people to sort of ask questions live and to review messages in the chat. I see there are several questions about things that I'm going to cover, and so I'm going to have an overview of what I'm going to cover in just a few slides. So I think I'm just going to press on and kind of get to that overview, and then if there are any questions after that, I'll take those. Okay, so if you're here, you probably know that there's been a lot of research going on in econometrics and differences. So I probably don't have to tell you that sort of differences is one of the most popular strategies for estimating causal effects, and that there's been a lot of kind of recent econometrics literature on differences, which kind of the explosion of lots of recent papers, I think, has made it hard for people to sort of keep up with what's going on, which is sort of the reason that these types of workshops exist. So to the extent that I've contributed to the explosion of papers that you need to be aware of, or your referees want you to be aware of, I apologize, but I will try and do my best to kind of right the wrong in the workshop today, and then also by providing other resources. So given the sort of wave of recent differences papers, I sort of did joint work with Pedro Santana, Alyssa Belinsky, and John Poe to try and sort of synthesize the recent literature on differences and provide some concrete recommendations for practitioners. So if there are topics that I don't cover today, including some of the ones that people have mentioned in the chat, like staggered differences, continuous treatments, stuff like that, which I won't go into too much specifics about today, almost all that stuff's in our review paper, so definitely encourage you to check that out. Today's workshop is going to focus mainly on the developments in section 4 of that review paper, somewhat selfishly, mainly focusing on my own work. But I guess before I kind of dive into the specifics of the types of stuff that I've worked on, what I want to do right now is just kind of give a high-level tour of sort of what are the types of things that people have been working on in difference and differences, and so you can sort of get a sense of what's going on in the literature, and then we'll sort of dive into the specific strand of papers that I'll be talking about today. Let me just see, look at the chat briefly. Donald has a question about sort of staggered methods and violations of parallel trends. I will talk about towards the end of the lectures today, so I think I'm going to postpone that answer until later. Emmanuel asked, can I share the Roth et al. Paper? Yeah, if you go to my website, which you should be able to find with a Google search, you can find the PDF there. All right, so as I mentioned, I'm going to try and do like a short overview of what's been happening in difference and differences. Before I do that, kind of to take a step back, you might ask, difference and differences has been around for a long time. You know, some of you probably learned about this maybe in undergrad, if not in like first year of graduate school. So a kind of question you might have if you didn't know anything about the recent literature is like, didn't we know stuff about difference and differences many years ago? Haven't we known about this for a long time? Why is there so much new stuff going on? And I guess my short answer to that would be that I think we have understood for a long time how difference and differences works in what I'll call the canonical difference and differences model. This is probably, you know, if you learned about difference and differences in undergrad, this is kind of the model that you saw. It has the following components. There are 2 time periods, and the treatment occurs in the second period for some of our units. So we have some units they're not treated in either period. We have some units they're treated in period 2, but not in period 1. All right, and so like canonical difference and differences example, the Cardin-Kruger minimum wage study. You have New Jersey and Pennsylvania, right? New Jersey raises its minimum wage in the kind of second period. Pennsylvania doesn't raise its minimum wage in either period, and so we sort of have New Jersey as the treated group that sort of their treatment turns on in period 2, and Pennsylvania is the control group that does. And then we kind of obtain identification. The key assumption is usually the parallel trends assumption. There's also something called the no anticipation assumption that says that the treatment doesn't have any impact in prior to the period that it was implemented. And those 2 things together give us identification of the ATT, that is the average treatment effect on the treated, that is the average treatment effect for the treated units in period 2, the period where they were treated. And then in this canonical model, estimation and inference are pretty easy. You know, we can take difference and differences of sample means, but that's the same thing as running a regression with unit and time to fixed effects. And if we have a lot of independent clusters, that OLS estimate is going to be consistent, and our usual clustered standard errors are going to give us valid confidence intervals. So this has been known for 20 plus years. It's a very simple model. They're very simple results about when things work, and we kind of know what's going on. The issue is that most difference and differences settings in the wild, if you actually look at empirical papers, while this canonical model is great and very simple, it turns out it typically doesn't match settings that people are going to study in practice. So there are very few difference and differences studies that actually have 2 time periods. Usually we have a lot more than 2 time periods. And often the treatment doesn't just occur in some fixed period, but some states will stay past the law that we're interested in 2005, some will pass it in 2007, some will pass it in 2009. So there are often more than 2 periods, and the timing of the treatment may not be uniform. And then sort of in terms of identification, we know what the parallel trends assumption means, but when we're in the wild and our treatment is not randomly assigned, liberal states are more likely to raise the minimum wage than conservative states, we sort of have questions about, is parallel trends a good assumption here? And so instead of kind of just assuming it, we kind of want to learn something about it from the data. We want to test to see, is it violated? We may want to do some sensitivity analysis. What if it's violated a little bit? Are our results robust? And so while we know kind of the identifying assumptions in the canonical case, we may be worried that those assumptions aren't satisfied in practice. And then in terms of kind of estimation and inference, it turns out that this consistency of two-way fixed effects, when we get to more complicated settings, that may be a bit more complicated. And then also in terms of our inference, we sort of need there to be many independent clusters that both get treated and untreated. But in practice, we may have settings where, say, 2 or 3 states get the treatment. And so these asymptotics based on having a large number of independent clusters may be kind of questionable in practice. All right. And so I guess I would say, if we think about kind of what's been going on in the difference in differences literature, we sort of had these 3 different sets of assumptions, kind of 2 periods, common treatment timing, parallel trends for identification, large number of sort of independently sampled clusters. And we can kind of think about a few different strands of the literature as basically relaxing one of these key components, typically preserving most of the other 2, although sometimes people will relax, say, 2 components at once. So there's been a large literature on sort of what happens when we have multiple periods and staggered treatment timing. These papers typically kind of maintain the other 2 branches, so they're going to assume parallel trends, they're going to assume a large number of independent clusters. We kind of think about what happens if we have multiple periods and staggered treatment timing. And in particular, a lot of these papers show that kind of the typical two-way fixed effects regressions that people were running don't necessarily converge to some form of sort of convex weighted average of average treatment effects on the treated. But fortunately, there are sort of new estimators that people have developed that have better properties under parallel trends and a large number of independent clusters. And then there's been a second strand of literature, which is what's going to be my focus today, which is sort of on relaxing the parallel trends assumption or allowing the parallel trends assumption to be violated, and kind of thinking about what can we learn if we're willing to sort of allow for some violations of parallel trends. So how well can we test, does parallel trends seem to hold approximately in the setting? And how can we account for certain violations of parallel trends? So that's going to be my focus today. And then there's also a third strand of literature, which is sort of focused on relaxing this assumption of having a large number of independent clusters. So there are some new ways for kind of getting confidence intervals in settings where you have, say, 3 or 4 treated units, something like that. So let me just pause here and look at the questions. Sally asks, will we cover continuous treatments? Unfortunately, the answer is no, for the most part. So I'll talk at the end, sort of a lot of the tools for allowing parallel trends to be violated work with a variety of different types of estimators, including some estimators that work with continuous treatments. So I'll talk a little bit about at the end about how kind of some of the tools that we talk about where we'll focus on the binary case, but how some of the tools that I talk about for dealing with violations of parallel trends can also apply in the continuous treatment case. But for the most part, I'm going to focus today on binary treatments. You can look at our review paper and the sort of complementary review paper by Clément Deschaise-Martin and Xavier Datfoy, on which sort of covers more stuff about continuous treatments. Demetria asks, what is considered small here? I assume that means small in terms of the number of clusters. So the kind of key thing in terms of getting good inference is sort of to have a large enough number of clusters that the central limit theorem is a reasonable approximation. If you took an intro to stats course in undergrad, the rule of thumb is often like 30 observations for the central limit theorem. That's a little bit made up. If you have 28 states, that's not very different from having 31 states. But certainly if you have, say, fewer than 10 treated states, I think you're probably in something that looks like a small number of clusters regime. Yeah, but I guess you can give rules of thumb, but sort of how well the central limit theorem works with a small number of observations also kind of depends on how skewed the data is. So if it's very skewed, then you need a lot of observations. If the data was magically normal to begin with, you actually don't need very many observations. But yeah, that's a great question. Let's see. Irakli asks, am I going to cover like the paper by Koski and Mai and co-authors when treatments turn on and off? I'm not going to cover that paper directly. Some of the tools that I'll talk about can be used at that type of thing. So I'll talk a little bit about kind of related estimators that the tools I talk about for sensitivity analysis can be used with, but I won't go into that paper so much directly. I also want to talk about synthetic control. I see some longer questions here, which I think maybe would be great to kind of hold in the back of your mind until the Q&A in terms of specific models like interacted fixed effects. I see some questions about that, stuff like that. So I think in the interest of time, these are all great questions I see here in the Q&A. In the interest of time, I think I'm going to stop here in terms of asking the questions, but sort of keep those in mind. Feel free to raise them again as I move on. So thanks a lot. Okay. All right. So let me just dive into the kind of the meat of what I want to talk about today. So as I sort of previewed earlier, kind of the way I'm going to set this up is I'm going to sort of first talk about kind of what is the parallel trends assumption, why might we be worried about it, and kind of what are some issues with the ways that commonly people test for the parallel trends assumption, and then I will sort of try to pivot to talking about solutions to these types of issues. All right. So as a kind of an outline of what I'm going to talk about today, I'm going to start out, say, with just a brief introduction. Probably most of you are familiar, I would guess, with kind of what the parallel trends assumption is, but we'll just talk about it a little bit to make sure everyone's on the same page. We'll then talk about, well, before we've seen any data, should we believe in parallel trends in practice? I'm going to argue that we might initially be skeptical of the parallel trends assumption. So before we've seen any data, we might be unsure as to whether it holds. And then kind of, I think, one of the reasons that diff and diff is so popular is that we can partially test the validity of the parallel trends assumption using pre-treatment information. That is what are typically called pre-trends. And so that makes a lot of sense. I'll talk about why it makes sense. But then I'll also spend a lot of time talking about kind of what are the limitations of those pre-trends tests. So, if we just look at the pre-trends and they aren't statistically significantly different from zero, can we just move on with our lives? I'll argue that, even if they're not statistically significant, we may still be a little bit worried. So then I'll kind of finish the lectures today by talking about alternative approaches when we're sort of worried about violations of parallel trends that kind of help address some of these limitations of pre-trends tests. So I see in the chat there are a couple of questions about self-selection and confounding variables. I think those are great questions because I'm about to talk about that in the next couple of slides. So I think I'm just gonna postpone those questions for now. Okay, great. So as I mentioned, what I want to start about talking about is like, what is the parallel trends assumption? Do we think this assumption is plausible in practice or not? To do that, I just want to set up a little bit of notation. Just for this discussion, just to make things really simple, we're going to consider the canonical two-period difference in differences model and talk about what the parallel trends assumption means in that context. The parallel trends assumption then generalizes to more complex settings, and similar issues will apply in the more complex settings. But let's just start with the simplest case possible. So think about a setting where there are two periods, t, 0 and 1. All right, we're going to observe panel data with outcomes yit for individual I in period t. And then there are going to be some units that are treated beginning in the second period, that is period 1. We'll call the guys who eventually get treated, we'll call those guys d equals 1. And the guys who are never treated in both period, we'll call those guys d equals 0. Okay, so d is an indicator for do you get treated in period 1. Right, and then we'll have the usual potential outcomes notation. All right, so yit1 is going to be your potential outcome if you eventually get treated. Yit0 is your potential outcome if you don't get treated. All right, so we observe the y1s for the treated people. We observe the y0s for the untreated people. And typically we assume what's called the no anticipation assumption. Oh, sorry, this is a typo here. So this should be, these t's here should be 0. I apologize. So put that in red so I fix these before we post these. That should be a 1. Sorry, that should be a 0. 0, 0. Right, so in period 0, your outcome doesn't depend on whether you ultimately get treated in period 1 or not. Right. Sorry, my pen. Right, so that's the kind of canonical difference in differences setup that'll at least give us enough notation to talk about what is the meaning of the parallel trends assumption, at least in the simplest case. All right, so what does the parallel trends assumption say? Intuitively, it says that if the treatment hadn't occurred, the average outcomes for the treatment and the control group would have evolved in parallel. So in the notation that I just told you, that says that the expected change in y0, the untreated potential outcome between period 1 and period 0, is the same for the treated group as it is for the control group. That is, the expected change of y0 between period 0 and period 1 on average is the same for people with d equals 1, the people who ultimately get treated in period 1, as it is for people d equals 0, the people who never get treated. So that's the statement of the parallel trends assumption as it's usually stated. I think that a useful way to kind of alternatively phrase the parallel trends assumption, which I think sometimes makes it a little bit clearer economically what it is saying, is to kind of rearrange the terms in this first equation I have here. So people know that expectations are linear operators. So if I have the expectation of a sum or a difference between two random variables, that's the same as the difference in the expectations of those two random variables. Right, so I have these 4 expectations here. I can just sort of rearrange them to get the following equality here on the second line, which intuitively says that the selection bias in period 1 is the same as the selection bias in period 0. What do I mean by that? By selection bias, I mean if the treatment hadn't occurred, so we're looking at y0s, what would be the difference in the outcomes between the treated group and the control group? So on the left here, I have the selection bias in period 1. This is the difference in y0. This is the outcome that would have occurred if the treatment hadn't occurred between the people who get treated and the people who don't get treated. So that's a form of, that's sort of representing the selection bias. It's, there's some things that influence the outcome other than the treatment that might be different between the treated group and the control group, right? So what this is saying, this restatement in parallel trends says there can be some confounding factors that are related to the treatment and impact the outcomes without treatment. They impact the y0s, but those confounding factors have to have the same impact on the y0 in period 1 as they do in period 0. So the sort of nice thing about parallel trends is it doesn't say we have to have randomization of treatments. If we had randomized treatments, both terms, selection bias terms, would be 0 in both periods, right? If not for the treatments, the outcomes would have been the same for the treated and control group if we randomized the treatment. So the parallel trends assumption says we don't need that. We don't need there to be no selection bias. There can be some selection bias. There can be some factors that are related to untreated potential outcomes and influence the treatment, but they have to have the same effects on the outcome, or to be more precise, on the Y0, the untreated potential outcome, in the period before treatment as they do in the period after. So this is what we often call a selection bias stability assumption. It says there can be some selection bias, so it's more flexible than randomization, but that selection bias has to be stable over time. So if you're more of a visual learner, you can sort of see the parallel trends assumption in this graph. So here I have my 2 time periods, period 0 and period 1. In the red dotted line, I have the expectation of Y0, the expectation of the outcome that would have occurred if the treatment hadn't happened for the treated group. So the treated group starts here, and actually, maybe I should start with the control group. The control group starts down here, right? And then they move up to here. And the parallel trends assumption says that if the treatment hadn't occurred, these expectations would have evolved in parallel. So this blue line, which is the evolution of the average outcome for the control group, is parallel to this red dotted line, which is the evolution for the treated group that would have occurred if the treatment hadn't actually happened. Right. And so the parallel trends assumption, you can see it here, is that this red line and this blue line are parallel. So if the treatment hadn't occurred, the average outcomes for these 2 groups would have evolved in parallel. And so we can also think of that just by geometry as saying that the gap between the treated and the control group, so the gap between like point A and point B, is the same as the gap between point C and point D, right? And so the gap between point A and point B corresponds to the selection bias in period 0. This is how different are the outcomes for the treated and the control group before the treatment actually takes place. And what the parallel trends assumption says is that this selection bias is constant. So if the treatment hadn't occurred, that gap in outcomes between the 2 groups would have been the same in period 1 as it was in period 2. Let me just see, are there any questions about what the parallel trends assumption means? I'm actually not seeing any in the chat, so I'm assuming that either people are familiar with this from beforehand or my explanation was clear. All right. And so then, well, why is the parallel trends assumption useful? Well, I see. So Theus asks a question. Could you explain again why randomization would be less flexible than making the selection bias stability assumption? I always understood this was the same for randomization, and this is given as one reason for controlling for observable T-1 differences in RCTs. Yeah, so in an RCT, if you randomize the treatments, it's just completely randomized, and there's no selection bias in either period. So if I determine your treatment by flipping coins, it can't be related to what your outcome would have been without the treatment. So basically, E of Y0, or sorry, E of Y10, given that you're treated, if I randomize, it would be the same as E of Y0, given that you're in control in both periods. So basically, if I randomize, selection bias in period 1 would be 0, and selection bias in period 0 would be 0. So I would get this selection bias stability, and both of the terms would be 0. The reason that parallel trends is a little bit more flexible is that it could be that this is not 0, so there's some selection bias. It could be that this is 1, say, but then this is also 1. So randomization corresponds to the specific case where both of the selection biases are 0, but here we're allowing the selection biases to be non-zero in each period, but they have to be the same. Let me see some other questions. And so just to go back to Abdi Aziz asked a question earlier, how does the difference in differences method address issues of confounding variables? So it's exactly this. It says there can be some confounding variables, but they have to have the same effect on the outcome in period 0 as they do in period 1. So it says there can be confounding factors, but sort of the selection bias has to be stable over time. An anonymous attendee says that some people argue that DID is more convincing if there is no pretreatment selection bias. I would agree with that, and I will actually talk a little bit more about that in just a minute. All right, so let me just push on just a little bit. All right, so we have the parallel trends assumption. We just talked about what it means. Why is it useful? Well, the reason it's useful is it allows us to identify the average treatment effect on the treated. So why is that? Well, recall our blue line from before was the Y0 for the control group. Well, the outcome that we actually observed for the control group is actually their Y0. So the observed outcome for the control group is exactly this blue line that we had before. Now, the no anticipation assumption says that the treatment doesn't matter for the treated group in the pre-treatment period, in period 0. So that means that the observed outcome for the treated group is actually the same as the outcome we would have observed if the treatment hadn't happened in period 0. That is, the solid line corresponding to the observed outcome for the treated group is the same as their Y0 in period 0. So someone asked in the chat, where does the no anticipation assumption come in? It comes in exactly here. This red line corresponding to the observed outcome for the treated is the same as this dotted line in period 0, where the dotted line corresponds to the untreated potential outcome. All right. And so now we observe the change in the outcome for the treated group, for the control group over time. So we observe this solid blue line. We know that if the treatment hadn't occurred, based on parallel trends, that the treated group would have followed this red dotted line. So we know that this point here is the counterfactual outcome for the treated units, right? But then we see that this treated group actually wound up here. So the gap between those is the treatment effect in period 2 for the treated units. That is the difference between their observed outcome over here and their counterfactual outcome down there. Right. So the fact that we know that the treated group and the control group would have been parallel if not for the treatment allows us to figure out what their counterfactual outcome is, and so allows us to infer that this is the ATT. It's the difference between their actual outcome in period 2 and their counterfactual outcome. I see Rajesh says no anticipation seems the same as the parallel trends assumption. Can people help differentiate? So they're not really the same. So the parallel trends assumption says if there were no treatment ever, the blue line and the red dotted line would have been parallel. So the groups would have moved in parallel. The no anticipation assumption says that the outcome for the treated group is not affected in period 0. That is, imagine, for example, that period 1 corresponds to a minimum wage change for the treated group. So it says that before that minimum wage change goes into effect, the outcome for the treated group is the same as it would have been if the minimum wage hadn't changed in the next period. So an example of when this would be violated would be if people know, it's 2005, but I know the minimum wage is going to increase in 2006, and I change my behavior in response to that. If that were true, then this red line, the observed outcome for the treated group, may not intersect in period 0 the dotted line, the counterfactual outcome. Like if people start firing low-wage workers in anticipation of the minimum wage changing, then if Y is employment, actually the observed outcome might be down here, whereas the counterfactual outcome would be up here. So the fact that these red, the solid red, the observed outcome, and the dotted red, the counterfactual outcome if the treatment hadn't occurred, the fact that these are the same in period 0 is exactly what the no anticipation assumption says. I see some people asking about spillovers. So spillovers are sort of implicitly ruled out here because we write the potential outcomes are like YIT of DI. This implicitly embeds that I's outcome only depends on I's treatment, doesn't depend on J's treatment. There's been some interesting work on differences with spillovers by Kyle Butts and co-authors and some other people that we talk about in our review paper. But for now, we're sort of not going to think about spillovers. June says, if we don't have selection bias, is the parallel trends assumption quite robust? The answer is yes. I mean, if you don't have any selection bias, if you randomize the treatment, then parallel trends is robust. It should be true. But then other things are true. So if you have an RCT, you don't really need to do diff and diff. You can just do difference in means. Parallel Pavinger, Santana, and I actually have a paper showing that if you thought treatment timing was random, you can actually always get smaller standard errors than using difference in differences. So generally, people are going to use difference in differences when they think that that there is some selection bias. Toyney says, prior to enacting a law or new policy, there's discussion about the law and there's understanding of whether it will pass months before. Does this violate the no anticipation assumption? So I think the answer is yes, but in a way that usually can be dealt with in practice, which is that if we think that there's some short-term possible anticipation, say, people know 6 months before the law is passed that it's going to go into effect, we can sort of redefine what the date of the treatment is to be, say, 6 months before it goes into effect. So here we kind of just had before and after. And so we need there to be no anticipation in the before period. But in practice, we usually have multiple time periods, and we can kind of decide when we say that the treatment starts. So if you're willing to assume that the treatment is kind of the anticipation effect is isolated to some short window around the treatment, usually what you would do is you just redefine to say, the start date of the treatment is when people could start anticipating it. That's maybe 6 months before the law passes. And so you can kind of deal with sort of local violations of the no anticipation assumption just by kind of redefining when the start date is. So if you just define the start date to be when you think people can start reacting, then you don't have any problem if people don't anticipate it sort of prior to that start date. So that's a great question. Okay. Someone asked, should PT condition on covariates? Sometimes, yes. I won't have a lot of time to sort of talk about conditioning on covariates today. We have a long discussion of that in the review paper. You can, if you want to think about conditioning on covariates, just think about all of this analysis, all these red lines, blue lines, dotted red lines, to be sort of for groups of people with the same covariates, right? So we can sort of think about doing this analysis among people with the same covariates. Say if we'd matched on covariates or done some controls, the idea is we need these groups to be in parallel, at least once we've gotten the right comparison group of people based on observable characteristics. Okay. So let me just press on a little bit here. And so we're going to think about why might we be skeptical of the parallel trends assumption. So recall the parallel trends assumption says there can be selection bias, okay, but it has to be constant over time. So if we're thinking about, say, the minimum wage, it can be that states that raise the minimum wage are different from states that don't raise the minimum wage, right? We might worry that, say, Democratic states are more likely to raise the minimum wage than Republican states. They may also have different employment levels to begin with, right? So there may be some selection bias. The types of states that raise the minimum wage are not the same as the types of states that don't, and so they may have different outcomes even before the treatment occurs, all right? And so we're then going to think about, well, parallel trends assumption says that's okay. There can be a selection bias, but that selection bias has to be the same in both periods, all right? So the states can be different, but the differences between the states, other than whether they pass this policy, have to be stable over time. So I guess here's a place where I'll open things up to the crowd. Does anyone have some ideas as to why might we be skeptical of this assumption of parallel trends, that is that the selection bias is constant over time? I'll maybe just pause here for 30 seconds and see if anyone wants to put into the Q&A some thoughts on why we might be skeptical of this assumption. I think this is a good place for you guys to kind of think about that on your own. Okay, so I'm seeing a lot of great answers in the Q&A. I can't address all of them, but let me just single out a couple of them. So I think two really good answers that relate to the first thing I want to talk about are from I think Ang, if I'm pronouncing that right, and Veronica. So Ang says that different states may respond differently to macroeconomic trends. So there might be sort of time varying macroeconomic factors. If say Democratic states are more likely to pass a policy, and they're also sort of more in the service sector and less in agriculture, say, then if there are macroeconomic trends that differentially affect, say the service sector versus agriculture, then they have a time varying kind of effect on the outcome. So there's sort of different macroeconomic factors that are different in both periods. And then another great answer from Veronica was that there were maybe other unknown treatments occurring. So kind of an unfortunate fact for econometricians is that states typically don't just do one thing at a time, right? As econometricians, it would be great if the states only decided that they were going to only pass one policy every year, say, but in practice, they often change multiple things at a time. And so as an example, states that pass a minimum wage increase, say if they do that when Democrats take over the state legislature, they may also pass other things that affect employment, say unemployment insurance. And so it could be that, the two states were relatively similar beforehand, so they didn't have much selection bias. But then afterwards, the states that pass the minimum wage also have different unemployment insurance. So there's a confounding factor that exists in the second period, this difference in unemployment insurance that wasn't there beforehand. So there may be some new confounding factors, particularly when states can pass policies, multiple policies at the same time. So if there are other policies that are passed at the same time as the one that we care about. So that's one thing. And then there may be some confounding factors that didn't exist in the pre-treatment period, but showed up later. Things like, it was a regular time beforehand, but now there was some sort of, new event that happened. So, in 2019, there were no differences in COVID rates between any states, but by 2020, there were some differences in COVID rates, right? So if you have, your treated states are more exposed to COVID, you don't have a confound in 2019, but you do have a confound in 2020 potentially. And so there may be some confounds that sort of exist in period one, but don't exist in period zero, either because other policies were passed at the same time in period one, or period one just has different types of factors that sort of didn't really matter in period zero. So that's kind of one reason we might be skeptical. There's some time varying factors. A kind of closely related thing is that there may be some fixed differences between the treated and the control group, but because something else changes, the impact of those fixed differences changes over time, right? So it could be that, say, we have a treated group of people who enroll in a job training program, and we have a untreated group of people who don't enroll in the job training program. So we might think that the treated people, the people who enroll in the program, are just more motivated to find a job than the people who don't enroll in the program. So that difference may be the same in both periods. The people who enroll are just more motivated before, and they're more motivated afterwards. But the impact of motivation on an outcome may matter more in some periods than in others. So suppose in period zero, the economy is pretty good, so you don't actually have to be that motivated to find a job. There may not be that many differences between these two sets of people. But if in period one, we have a recession and it's hard to find a job, you have to be really motivated and apply to a lot of jobs, then this impact of motivation may matter more in the second period. So it's not just that there have to be new confounding factors, but it could also be that the confounding factors that exist just matter more in different periods, such that the impact of that different confounding factor will be different in period zero versus period one. Or in other words, the selection bias, the difference in the outcomes owing to that confounding factor will be different in period zero than in period one, and so parallel trends will be fixed. All right, I'm going to press on just a little bit here. There are a bunch of great questions in the chat, but for the moment, let's push on a little bit more. All And so we've talked about two reasons why you might be skeptical of parallel trends, either time varying factors or time varying effects of sort of fixed confounding factors. A sort of issue that's closely interrelated to this is that the parallel trends assumption will typically have its validity be dependent on the functional form that we use for the outcome. What I mean by that is whether I use, say, the levels of the outcome or the log of the outcome or some other transformation of the outcome on the left-hand side, the parallel trends assumption may depend on which of those things that I choose. So to see why this is the case, consider a very simple example. In period 0, all control units have outcome 10 and all treated units have outcome 5. So there's a difference of 5 between the outcomes of the two groups. There's a difference in outcomes between the two groups of 5 in the period before the treatment. Sorry for the pause. I'm like trying to read the chat at the same time as I talk and can't do either of those super effectively. Sorry about that. So beforehand, control group is at 10, treated group is at 5. In period 1, after the treatment occurs for the treated group, we see that the control units go up to 15. Okay. So if we did parallel trends in levels the usual way, we would say the control group increased from 10 to 15. That's an increase of 5, of course. If we assume parallel trends, that means that the treated group would have gone from 5 to 10, right? So that's parallel trends in levels. But you might also say, well, the control group, they went from 10 to 15. That was an increase of 50%. Well, the treated units started at 5, so they had if they had an increase of 50%, they would go from 5 to 7.5. So you can see that these two things lead to a bit of a tension, right? If we assume parallel trends in levels, we would say that the treated group would increase by 5, so they would go from 5 to 10. But if we did parallel trends in logs here, we would roughly say that the treated group should go up by 50%, so they should go up from 5 to 7.5. So depending on whether we assume parallel trends in levels versus parallel trends in logs, we're going to get something different in terms of how we infer the counterfactual outcome for the treatment. And this is related to what we talked about before, because when we say the selection bias is stable, we sort of have to say that what that means in terms of a particular functional form. So does the selection bias being stable mean that the gap between the two groups is only 5, or does the selection bias being stable means that the gap between the groups is 50%, right? Those are each different ways of sort of formalizing what it means for the selection bias to be stable, which kind of depends on the functional form that we've chosen. So if we've chosen levels, it means the raw difference is the same. If we focus on logs, up to sort of Jensen's inequality, making things a little bit weird, we sort of mean that the difference is in percentages. Oh, sorry. So you would think I would know how to cite my own paper, but I guess I didn't get LaTeX to work. So this is question mark here. The question mark to be filled in should be Roth and Santana 2023 econometrica. Sorry about that. Let me just make this in red. All right, so in my paper with Pedro Santana, we sort of formalized this dependence on functional form, and we show that parallel trends will depend on functional form unless we're in sort of one of 3 kind of very specific situations. The first is where we have randomization. So the treatment and the control group have the same distribution of Y0 in each period. The second is where we don't necessarily have randomization, but there aren't any important time effects. So the distribution of Y0 for each group is the same in period 0 as it was in period 1. And then the third case where we kind of can have parallel trends hold for all functional forms is sort of a hybrid of the first 2 cases where we sort of have some subset of the population that looks basically as good as if it's randomized, and we have a remaining subset of the population that sort of doesn't have any important time effects. And so there's some cases where we think these types of things might be plausible. So if, for example, our 2 time periods are very close together, then there may not be sort of many time effects, or we may think that the treatment is approximately randomized. or some combination thereof. But absent these kind of relatively specific conditions, parallel trends will sort of be violated for at least some functional form, like we sort of saw in the previous example, depending on whether we assume parallel trends is stable in levels versus stable in percentages, which is roughly equivalent to parallel trends in logs, then we sort of get a different answer depending on which functional form that we assume. And so even if we kind of think there aren't that many time varying factors that are changing across these groups, it's a little bit hard to say, do we think do we think selection by stability means constant level differences versus constant percentage differences versus something in between? It's often a little bit hard to choose. So sorry, I see Raul ask, what does UI mean? UI is an abbreviation for unemployment insurance. So sorry if that was unclear. Okay, great. Okay, so I've hopefully kind of convinced you that in many differences settings, we might have reason to be skeptical about the parallel trends assumption. We might think there's some time varying factors that differentially affect our treated and control group. We might think that we're not sure, does bias stability mean parallel trends in levels versus logs? And so we might be skeptical before we see any data of the parallel trends assumption, or we might not be sure that it holds. But kind of one of the nice thing about the parallel trends assumption, or the differences design, is that the identifying assumption is at least partially testable. So in many DID applications, we have several periods before anyone was treated. And so we can test whether the groups are moving in parallel prior to the treatment. If it looks like they were moving in parallel in many periods prior to the treatment, then it seems sort of more plausible to assume that whatever confounding factors might exist, those seem to be relatively stable before the treatment. And so it's more plausible that they would have been stable afterwards. Of course, this isn't perfect, because if there were some confounding policy change, we would expect them to be, parallel beforehand. But if I pass unemployment insurance at the same time as, I raise the minimum wage, then that's not going to show up beforehand. Or if I'm looking at COVID cases, if I look at COVID cases in 2018 and 2019, those are going to be super parallel, but that doesn't really tell me much about whether they would be parallel, between 2020 and 2021. So this isn't perfect in terms of telling me the plausibility of the parallel trends assumption after the treatment. But for many types of things that I might be worried about, like varying macroeconomic factors, if they look like macroeconomic trends don't have a differential impact for several decades beforehand, it seems relatively plausible to think that macroeconomic factors are going to be the same afterwards if the treatment hadn't occurred. All right. So if the groups are moving really in parallel for many periods before the treatment, parallel trends assumption seems more plausible. If they weren't moving in parallel beforehand, they had really different trends beforehand, then in theory, it's possible that they would have magically started moving in parallel afterwards, if not for the treatment, but that's generally going to be hard to believe. So if we know they're really parallel beforehand, we're probably more confident about the parallel trends assumption. If we don't know, if we see that they're really not moving in parallel beforehand, then we might have to do something else, because the parallel trends assumption is generally going to be pretty problematic. All right. Okay, and so testing repeat trends provides sort of a natural plausibility check on the parallel trends assumption. And so this is sort of a pretty natural thing to do. So to give you an example, and this is actually the example that when you go to the coding exercise later, it'll be sort of based on this paper. They use some proprietary data, so you'll have some public use data, but it'll be sort of basically the same economic application. And so this paper by Carey, Miller, and Wary, Sarah Miller's at Michigan, by the way, is sort of doing a difference in differences, comparing states who expanded Medicaid in 2014 to states that didn't. Roughly speaking, so we're going to normalize the difference between the treated and the control group, that is states that expand versus states that didn't, to 0 in periods before they expand. And so then this is sort of this period 0 coefficient here is the diff and diff between the period before the treatment and the first period in which this treatment, the Medicaid expansion, exists. So this is comparing changes in outcomes for states who expanded Medicaid to changes in outcomes for states who didn't expand Medicaid. And you can see that the uninsurance rate somewhat intuitively seems to go down for states who expand Medicaid following the Medicaid expansion. But what I want to focus on here is kind of the nice thing here, that basically all these diff and diffs in prior periods seem to be pretty close to 0. And so, we might have been worried ex ante that Democratic states that expand, maybe they have other things going on that affect healthcare more so than Republican states. You can see that at least in like the sort of 6 periods before the Medicaid expansion, which primarily occurred in 2014, that these groups were at least up to statistical precision, moving relatively in parallel. And then there's a much larger drop when this Medicaid reform actually goes into effect. And so that gives us some more confidence that, it's not just when the economy gets better that Medicaid expansions that insurance tends to go down and more in Democratic states than Republican states. Given that there was a lot of economic variation between 2008 basically and 2014, we see here that it seems like, at least up to this statistical precision that we have, those economic factors that changed between 2008 and 2014 didn't seem to be having a very large differential effect for the types of states that passed the Medicaid expansion versus the types of states that did. All right. So that gives us some additional confidence in the parallel trends assumption if we see that the groups are moving in parallel. And so it's a very natural thing to do, but it's not perfect. And so I think, I don't want you to take away, don't make an event study plot. For sure not. You definitely should make event study plots and look at them. But this approach of sort of, let's look at the data and see whether it supports the parallel trends assumption also has some limitations highlighted in recent work, including Freyoldenhoven, Hansen, and Shapiro, Conling and Lang, Balinci and Hatfield, and some of my own work. And so for the remainder of what I'm going to do today, I'm going to sort of talk about what are some issues with the common practice of testing for pre-trends. And then I'll focus on some solutions. And for the most part, I'm going to focus on 2 of my papers, my 2022 AR Insights paper, Pre-test with caution. Roughly speaking, this paper is about problems. And then the second paper, my paper with Ashish Ramachan, is about some solutions. So what we're going to do is we're going to think about sort of what are issues with pre-trends testing, and then what are some solutions. I think at this point I've actually been talking for quite a while, so I think I was scheduled, according to the schedule I put up earlier, to end this first lecture at 10:15. I'm not quite through the material I plan to cover, but I have a feeling that people's sort of attention span may be waning very slightly after being here for an hour and 20 minutes, and people may have to go to the bathroom and stuff. So I think what I'm going to do is I'm going to pause here, and let's take like a 10-minute break. So it's basically 10:20 Eastern time. So I think I'm going to pause here. I'll let you guys break from 10:20 Eastern to 10:30 Eastern, and then I'll just pick this up again at 10:30. So I think why don't you do whatever you got to do, bio break, coffee, whatever, and we'll reconvene here in 10 minutes. And I'm going to step out to the bathroom briefly, but I'll be back in about 5 minutes. So if people have some questions in the Q&A, I can sort of try and do a little bit of that during the second part of the break.